Good evening everyone. Dear students, today we are going to start our classical mechanics series, and the first topic in our series is mechanics of a particle. Dear student, before we are going to study the topic of mechanics of a particle, we have to understand the idea of a particle. Means what is the particle in classical mechanics? Means in daily life we generally say a dust particle, a sand particle. Do you and me qualify to be a particle in classical mechanics? Or a flying aeroplane is a particle? Or our earth or our solar system is a particle? Students, particle is very trivial word which come across in our daily life. But in classical mechanics, particle has certain specific meaning. For example, in quantum mechanics, dust particle is not a particle. And in classical mechanics, even our earth can be a particle. It depends on the situation. So students, in classical mechanics, particle means the situation in which we can ignore the size of the object, then we can say it is a particle. For example, students, earth is very big, but when we consider the motion of earth around sun, we can consider earth as a particle. When we consider the relative displacement of our solar system with respect to some other galaxies, our solar system can be considered as a particle, which is so huge, but still it can be considered as a particle. In daily life, we can consider a bus a particle if it covers such a large distance that you can ignore the size of the bus. So student, let's consider such a particle which is moving in three-dimensional Euclidean space. Student, we can easily generalize the two-dimensional motion of the particle into three dimensions. So for our simplicity, we are going to take the motion of a particle in a plane. Student, we have a particle and it is moving in arbitrary, some crazy manner like this. And its sense is this. It's moving in this way. So to describe the mechanics of a particle, we need some dynamical variables. Like, dear students, you know cricket, you know football. To understand these games or to watch these games, you must be aware with some terminology related with these games. For example, if we consider the game of cricket, you must aware with some of its terminology like over, runner, wicket keeper, bowler, batsman, hit wicket, LBW. There are some words like LBW. This LBW is not coming across in any kind of other game. In the same way, to explain the mechanics of this particle, this is also like a game. Game has certain rules. This is also having certain rules. So to explain its mechanics, we need some dynamical variables. And the first and the most simplest type of variable which I need is its position. So first of all, I have to locate its position at any point. Arbitrarily, I have selected 2 points on its path. One is, say, point P, and the second is, say, point Q. But student, we have to describe their position. But position with respect to what? So with respect to a point called reference point, again, what is the meaning of reference point? Now student, suppose you belongs to a village or any hamlet. Then I ask you, dear student, I would like to visit your home. Please give me the address. How can I locate your home in your village? You will say, sir, you can come to our village and ask someone in the village that where is the post office, because my house is located very near to the post office. So here post office can be considered as a reference point, because post office in a village is very well known to everyone. So locating post office, then locating your home is very easy. In the same way, to locate this point P, I must have to find out a reference point, and in two-dimensional Euclidean space in our rectangular coordinate system, origin is a very well known point. So student, here origin can be taken as the reference point, and with respect to this reference point, we are going to take the position of this point P. So student, in two dimensions, let the position vector for this point is RP. RP is the position vector for point P. In the same way, RQ is the position vector for point Q. These two points P and Q are selected arbitrarily on its path. This is RQ. Student, the path of the particle, this red one, is known as the distance or the path length of the particle between point P and point Q. And dear student, if I connect point P to Q with an arrow which is directed from P to Q, this arrow has direction from P to Q. I would like to call this vector delta R, which is my displacement vector. So red line is the path length or the distance, and the white arrow is the displacement vector. And we are also going to attach one more variable with this motion, and that is independent variable, that is time. The point P, the particle at point P is at time t, and after time delta t, it is at point Q. So we can say the particle takes time delta t in moving from P to Q. Student, t can be, you can say t is 10 am and t plus delta t is 10:02 am. Means the particle has taken 2 minutes in going from P to Q. So delta t is a very small time interval. Dear student, delta R is the displacement vector when divided by the time taken by this particle in moving from P to Q. This quantity is known as the average speed, the average velocity of the particle. If the time interval is very small means if this time interval tends to 0 but not 0, in that case we will write this formula as delta R by delta t limit delta t tends to 0. Student, if this delta t tends to 0, in this case we have taken delta t as 2 minutes. If we take it as 1 second or 0.1 second, 0.01 second, 0.001 second, 0.00001 second, it is the meaning of tending to 0. So student, if we take the time interval very very small, then point Q will be very close to point P. In that case, this quantity from the mathematical definition is known as the differentiation of R with respect to time t, and this quantity gives you the rate of change of displacement with time, and this is known as your instantaneous velocity, or you can say it as simply velocity. Student, let's denote this velocity with a symbol V. So dear student, V is dr by dt. Please dear student, do not confuse with the average velocity. Average velocity is different from the instantaneous velocity. And student, when this instantaneous velocity V is multiplied with mass, if velocity is instantaneous velocity or velocity can be used interchangeably at any time. But dear student, again beware that when we say velocity, it means instantaneous velocity. It doesn't mean average velocity. Yes, they can be equal. Average velocity and instantaneous velocity can be same thing if the object is moving uniformly in a particular fixed direction. But this is not the case. It is not moving in a fixed direction. It is moving in a crazy fashion. It is not moving in a straight line. Now student, when the velocity of the particle is multiplied with its mass, we get a new vector which you know, which you are very familiar with, linear momentum. Student, what do we mean by mass? First of all, we must have to think about this. You will say, what to discuss about mass? Mass is mass. Mass is very common. I know it's very common, but just let me share my views with mass. The student, suppose you have some friend. You have more than one friend. Suppose you have two friends, X and Y. Say X and Y. You have two friends. One friend is X and the second friend is Y. And dear student, you treat both your friends equally, but still their response for your treatment will be different. For example, you give a surprise gift to X, and X will be, oh, I love you, you give me a surprise gift, you are my true friend. It means he is very excited. If you give the same surprise gift to Y, he will or she will say, okay, good, nice. Student, you treat them equally. You give the same surprise gift to both X and Y, but the response was different. In the same way, when you apply force on something, how that thing is going to respond you back is mass. For example, luckily I have this one. I have a basketball, kids basketball, and I would like to ask you, just please kick it, and you will be very happy to kick it. Okay, kick it means you are applying some force on it, so you can easily kick it. But dear student, if I have a stone of the same size, a large, or not large, a stone of the same shape but solid in form, and again I will say, please kick it. I know you are not going to kick it, because kicking it will give you a serious injury to your leg. Because student, in first case the mass is small, so when you kick it, it means you are applying some force. It will respond you to your leg, but that response is not so harsh. But in second case, when it is a stone, you are not going to kick it. If you are going to kick it, if you are going to apply some force on it, it will respond in a very harsh manner. So student, when you interact or when you apply some force on any object, how it is going to respond to you is the mass. Although it's very trivial idea, mass is very trivial, but not so trivial, I think. It is the, you can say, means of communication with any object by you. Our earth is revolving around sun. Sun is not revolving around earth because of their mass. So student, linear momentum is mass times velocity. Why? What is the difference between velocity and momentum? Means just simply multiplying a vector with a scalar, we get another vector which is having the same direction as that of this velocity vector. So why we multiply this velocity vector with mass? Means what is drastically changing by multiplying a vector with a scalar, and why we multiply it? Is the velocity is not sufficient? So student, let me explain you why we use m into v. Because student, it's natural law, means it's the nature or it's the law. What is the law? Student, if you have a basketball and a football, because they both have different mass, they may have same mass, but in this case, in this example, we are taking we are considering that they are having different mass. And I again would like to request you, please kick them one by one. You kick the basketball, you kick the football. The mass of basketball is greater than mass of football. You kick both these balls equally and similarly. It's I am assuming. Dear student, mass of basketball is greater than mass of football. So basketball will move with smaller velocity because the force is same for both. If you are kick equally to these balls, basketball will move with smaller velocity, football will move with larger velocity, but the force is same. But student, the product of their mass and velocity, the product of mass of basketball and velocity of basketball will equal to the mass of football and velocity of football. It means if you apply the same force for basketball and football, their m into v will be same. That's why we multiply mass with velocity, because this is a, you can say, natural vector, because if f is same, p will be same. That's why we need this p, and that's why we multiply m with v. So student, p is our linear momentum. Now student, if our particle is interacting with some fields, or interacting means some force is acting on the particle, then a force will act on the particle. In that case, our Newton's second law contains the mechanics of the particle, and according to Newton's second law, F equals dp by dt, which is the rate of change of linear momentum with time. This is Newton's second law. Now student, p is mv, and m can be taken out of this integral, differential, m dv by dt. Here I am assuming m is constant. Again, dear student, m is constant. Very simple line, but not so simple. Here m is constant means m is not changing with the velocity. Means we are actually sneaking into theory of relativity. Means if m is constant means m is m naught. Here m is constant, means m can vary. M can vary during the course of motion. For example, in case of rocket, when a rocket goes in outer space, the fuel it consumes is thrown out of in the form of gases. So its mass is continuously decreasing with motion. So I am not considering that kind of change. For example, this is a cracker which we generally use to on some festivals. I have ignited this cracker and throw it into the air. It is going to explode in mid of the air. Its mass is going to change during the course of motion. But dear student, we are not considering that kind of constant of mass. Here we are considering m is constant, means the velocity of the particle is not so large as compared to it's not so large that its mass is going to change, and we have to use m equals m naught over 1 minus v square by c square root, means we are not going to use this relation. So student, m is constant means we are not using this. We are dealing with normal velocity, few kilometers per hour, few meters per second. Next, dear student, dv by dt has certain name which we call acceleration. So f can also be written as ma. And dear student, there are certain frame of references in which this equation is obeyed. And dear student, this can also be written in the form of m d2r by dt square, because I have substituted the value of v from this equation. Dear student, Newton's second law is a second order differential equation. And student, here there is an assumption in bold. F equals m d2r by dt square. This equation has certain assumption that force is not depending on the higher derivative of r. It is just depending on the second derivative of r. And student, again I am saying there are certain frame of references in which this equation is valid, or in other way you can say those frame of references in which this equation is valid is known as Galilean frame of reference or inertial frame of reference. And by using this line we can also say, can we say that Newton's second law is a definition of inertial frame of reference? No, it's not a definition. It's actually the law which every body in motion is obeying under certain restrictions or certain constraints, like the velocity must be very very small as compared to the velocity of light, and the force is not depending on the higher derivatives of r. Student, that was the mechanics of a particle. Please, you may take its screenshot, and thanks for watching the video.